All right, welcome everyone to another weekly Cybersecurity Reloaded workshop. This week's workshop, I'm going to be talking about API security, more so on the type of protocols or architecture that they use to make sure that APIs transfer data without people being able to be middlemans or hack anything. So to go over what I've been talking about in previous weeks, as a recap, API stands for Application Programming Interface. This is a general term that can be pretty much used in a lot of areas. When we think of API, we usually think of web APIs because that's where most people use them. But anything from importing modules on Python as such, that's technically an API because you're abstracting away parts of the programming interface. The reason APIs keep getting more and more popular is because companies want developers to use their data a certain way. They want to make sure that the data they're giving out is protected and secure. And developers like to have an easier job, so APIs make it to where you don't need to know all the bare bone parts. You just need to know the commands that the company with the API is giving to you. And so API security, it comes because you're sending data, or as a company, you're sending data to a third-party client. And so API security is protecting the integrity of the API and the information for ones that you use, and maybe if you own one as well. I don't own any APIs, but I'm pretty sure that if I had a database that people were requesting data from, I would want to make sure that that data was secure. So with web API security, the two focus points or the two common implementations are called REST and SOAP. I'm going to talk a little bit about SOAP, but today's mostly going to be talking about the REST API. And so what's SOAP API? It's not a bar of soap like this Dove bar right here. It stands for Simple Object Access Protocol. This is the standardized protocol that's set by like the World Wide Web organizations and all that. And it's basically a protocol that tells you as a user how you need to send messages. And the messages are sent using other protocols like HTTP or SMTP. The problem with this being an official protocol, it has really strict rules and the security is advanced. So enterprises use SOAP usually, but the problem is it's not lightweight. So loading pages, it might be pretty slow compared to what we're used to nowadays. Everyone wants their web pages to load super fast without any hiccups. And SOAP causes issues because of how much restrictions are with it. And so this is where REST API came. The main thing to look for is the representational in the name, or RE, representational state transfer. This API or layout for an API is no longer a protocol, but just kind of an architectural style. It lays out guidelines that as a user or as a company you have to follow to have a RESTful web service. And this allows flexibility because they don't limit you on what messaging format you can use. Unlike SOAP, the only way you can send and receive data is using XML, which makes it a little bit difficult because XML might not be the fastest messaging format to send data through or send data with. So you'll see a lot of REST APIs using JSON because JSONs are easy to format in ways that programming languages or people know how to read. And so the main idea is that REST was meant to address the slowness of SOAP. And so nowadays, most things use REST. Loading times are much faster, which is why you see it everywhere. And so where do you see RESTful applications or APIs? You see it in Facebook, Twitter, Dropbox. Basically, any large company is going to be using RESTful APIs because It's just a set of rules that make it easy for both the company and the client to access data. I didn't put Spotify on here. I keep talking about Spotify. They're also a RESTful API. I'll go on their website in a minute and show you kind of how this all ties in. But one of the main ideas to understand with REST is, or it's called kind of like guiding principles or constraints. There's 6 constraints that have to be satisfied for you to be considered a RESTful web service or to have a RESTful API. The first one is client server. What this basically means is that you as the user or the client requesting data and the server holding the data should be separate. There shouldn't be anything interlinking them. So if the server decides to expand and grow, that shouldn't affect me as a user. I should still be able to request data in the same exact way. The second constraint is statelessness. This means that all session state information is held on client side. So it's basically the server's not holding any additional information. So as a client, you need to send over all the information that would need to be present to make a request, because the server shouldn't be holding any cache. But for the third constraint, there is cache that can be held, but this is the opposite way. So servers need to tell the client, or you, if you're requesting data from an API or a server, when they send data back to you as a response, they should tell you what information can or cannot be cached. Because sometimes simple things like, say, you're asking an API for the weather, you're probably not going to want to cache the weather because the weather changes every hour or so. So you wouldn't want to cache weather because that doesn't make much sense. But if you're caching, say, someone's username, that's probably not going to change very soon. So if you're doing a request saying, hey, what's so-and-so's username? You get a response from the server. It's probably going to say cache this result and save it for later. The fourth constraint is a uniform interface. Basically, this means that as a client, I can access information the same way on every device I'm on. There's no trickiness or different way of getting information from the server. So that's the fourth one. The fifth one, layered system. All this means is that there's layers in the architecture that allow certain elements to be hidden from other elements, such as a layer that I talked about a lot with Spotify, and its restrictions were if you want to add songs to a user's playlist, you would need to have authentication of the user to do that. So that would be a layered part of the system. You wouldn't be able to add songs to a user's playlist unless you have their authentication, but you can search up songs, and searching songs doesn't require that level of access. And so that's what a layered system allows for. And the last one, which I won't talk about a lot, is code on demand. This basically means that a REST API allows the possibility to download code snippets. So as a server, if someone sends you a request, you have the option to send back a response with an executable, and then the client can run the executable if that's what they wanted to run. And so that's a lot of information in one slide. Basically, what you're looking at here is you're not going to remember all of this. With REST, it's just an architect style. This is the guidelines you follow. So what this page should be showing you is that whenever you're using an API, you should take note of all these different things that it's, or all these constraints it has, because most APIs that you're going to be using, such as Google, Spotify, Facebook, Twitter, they all have these constraints within them because they follow the same set of guidelines. And diving deeper into, I believe, the fourth constraint, uniform interface. So there's, with REST APIs, what is called or there's a thing called a resource, and a resource is basically anything that is identifiable. So usernames, passwords, in the case of Spotify, things like song IDs, artist IDs, playlist IDs, everything is a resource, and every resource has to have a unique identifier. So you'll see the term URI kind of tossed around a lot with APIs. URI stands for Unique Resource Identifier. It's almost the same thing as URL, which everyone kind of knows, Unique Resource Locator. But the main idea with this is that every resource has a unique way to identify it, so that if you need to access that resource in the server, you're going to be able to access it. And this right here is saying resources are layered. There's, like I talked about with the adding songs to playlists, there's certain resources that can't be accessed unless you have access to a higher level one. I would say with this photo I have right here, this is kind of an example of what's going on there. Username here and password are both resources. They're each their own, or they should each have their own URI. And then within them, or within the validation factors resource, there's a thing called name and value. So the way, or the name and value are basically just giving the IP address of a certain user. But the validation factors, to access the name and value, you have to have access to validation factors. And so it's the resources are layered. And this screenshot here is of JSON, because most of the time when you're requesting API data, it comes in this form, in a JSON format. And another thing to touch on is the resources versus representations. The reason why people like using REST APIs or making their web services RESTful is that it's representational, like in the name representational. That means that the server itself isn't directly being manipulated. So in my examples in previous workshops where I was adding songs to my playlist and such, I wasn't calling Spotify server and saying, hey, change or add these songs to my playlist. What was actually happening was I was creating a new representation of my playlist. So I was creating a playlist with that song included. And then I was telling Spotify, hey, can you update your representation of my playlist? This is more secure, or this is where the security comes in, because no one has direct access to a server. They're basically just requesting representations from the server, which come in the form of JSON like this. This would be a typical example of something you would get if you did a GET request. And this is a representation of, say, someone's username and password on a server. If you wanted to update this username and password, you would update it, and then you would send it back with a put request. But nowhere in that exchange of information did the client actually go into the server and change the data themselves, which is what helps make everything secure with the transfer of information. And so let me take a second to go back to my internet, and I'll kind of show how this all looks using Spotify's website, which I've been trying to get to learn how to use. So their web API starting page talks a lot about this. It says that Spotify's web API is based on REST principles, and it uses HTTPS to request data or post data, such and such. And it explains how they're all put in place. And so this is why people like REST is, it's not putting guidelines on how to do it. It's just saying that you should use HTTPS to send and receive data. And then Spotify gets to tell you how they want that to be processed. coming down, you can see Spotify URI, which was the resource identifier I was talking about. Resource identifiers are used for everything on Spotify. So this right here in the example, this track name right here, that is a URI or one resource inside Spotify's server. And this here is the ID of that URI, such and such. You can find URIs of pretty much anything because they're unique resource identifiers. And with that, I'll stop there because that was about all I wanted to touch on today. These were some of the sources I was looking at for those interested in it. And with that, that was today's workshop. Thank you.